Today I will explain you proportionals and non-proportional relationships and how to identify if a table is proportional or non-proportional and if a graph is proportional and non-proportional. Before to start with this topic, you have to remember the definition for proportions. Remember, proportions basically is the equality of two ratios, or it's a when you compare two ratios, you have the same quantities. For example, here we have the formula for the constants of proportionality, that is k equals y over x. Always we are going to use this constant of proportionality to express or to identify the proportions or non-proportions. Or you can use y equal k over x. So that means that this number, this letter that is dividing, or this variable, we pass to multiply, and we are going to have y equals k times x. This is the constant for proportionality, and you're going to use in tables to identify if it's proportion or non-proportion. As you can see here, we have the two ratios, and we are going to compare this one that we have apples and trees. So you're going to identify if this table is proportional or non-proportional. In this case, this table is non-proportional because when you divide every value, or it's a y over x, for example, here we have 26 over 2 give us 13, so it's 13. In the next one give us 13, 13, 13, but in the last one, as you can see, we have 12.16. So these fourth values are equal, but the last one are different. So that means that this table is non-proportional relationship, because remember the definition. When you divide y over x, or it's a when you use the constant of proportionality, need to be the same value. And in this case, in the last part, we have a different value. So for this one, when you divide these values, every value, you get always 5. So the constant of proportionality in this case is 5. So this table is proportional relationship. Now I'm going to explain you how to identify proportionals and non-proportional relationships in graph. So I have these examples. When we work with graph and we need to identify if it's proportional or non-proportional, we're going to use two conditions. The first one, the line need to be linear. And the second one, this line need to start from the origin or need to pass through the origin, or it's a 0, 0 in the coordinate plane. So in this case, we have the ratios, water use and water and time. We have this proportion, and we have this difference. Remember, 2, we have 0, 0, 1 and 5, 2 and 10, 3 and 15. So we have this one, and in this case, as you can see, the first condition, that is linear, or we have it. But in the second one, we start from the origin. So this table or this graph is proportional. This graph is proportional. In this one, as you can see, this is linear. We have the first condition, but the second condition, that this table need to pass through 0, or it's a this line need to pass through 0, we don't have it. So in this case, it's non-proportional relationship. In here we start from the origin, so we have the condition number 2, and it's linear. And you can see if you connect all these points or all these ratios, you're gonna have a linear or a line. So in this case, it's proportional. In this case, we have this graph passed through 0, 0. And we have the second condition, but as you can see, this one it's not linear, so it's non-proportional relationship. So that's the reason, or that's the way that you can identify if a graph is proportional or non-proportional relationship. Remember, you have to have these two conditions in every graph, and with the table you're going to have the same constant of proportionality. The constant of proportionality is this one, 13. These are the constants of proportionality, but we have a different value, so it's non-proportional. And in this case we have the same value, so it's proportional.